I am now proceeding on to questions. First, I will prepare a list of formulae for inverse trigonometrical functions, and then we will take up some questions. Now, d by dx of sine inverse x is 1 over under root 1 minus x square. We have proved this result. And d by dx of cos inverse x is minus of this. As an aid to memory, we know sine inverse x plus cos inverse x is equal to pi by 2. And differentiating this, we have d by dx of sine inverse x plus d by dx of cos inverse x, and d by dx of pi by 2 is 0. And this implies d by dx of cos inverse x is equal to minus d by dx of sine inverse x. So d by dx of cos inverse x minus d by dx of sine inverse x. And similarly, tan inverse x plus cot inverse x is pi by 2. And therefore, d by dx of tan inverse x plus d by dx of cot inverse x must be equal to 0. And therefore, d by dx of cot inverse x is equal to minus tan inverse x. And similarly, for secant and cosecant, we have d by dx of cosecant inverse x is minus d by dx of secant inverse x. d by dx of cosecant inverse x is minus d by dx of secant inverse x. And you can memorize these results. Now I take up some questions. You must memorize the results for inverse trigonometrical functions which you have studied earlier. You must go through those results. Now first is y is equal to tan inverse 1 minus cos x over sin x. And we can write this as tan inverse of 1 minus cos theta. 1 minus cos theta is 1 minus cos of 2 theta is 2 sine square theta. 2 sine square theta. So this can be written as 2 sine square. It was 2 theta. So here it was theta. So when we have x, we will have x by 2. Half of this. And this can also be changed into x by 2. We can write 2 because we know sine of 2 theta is 2 sine theta cos theta. 2 sine theta cos theta. So we can write this as 2 sine x by 2 cos x by 2. We can write this as this and this as this. Now what we do is we can cancel this 2 with this 2 and sine x by 2 with sine x by 2. And we are left with tan inverse. This is sine x by 2 whole divided by cos x by 2. And this is equal to tan inverse of tan x by 2. Tan inverse of tan x by 2 is x by 2. This is equal to x by 2. This is x by 2. So we have changed this into tan inverse tan x by 2, and we know f of f inverse is identity. Ix is x. So this is equal to x by 2. And therefore dy by dx is equal to 1 by Now in this question, if we interchange sine and cos, what we get is y is equal to tan inverse 1 minus sine x whole divided by cos of x. Now we do not have any formula for 1 minus sine x. So what we do in this question is, because a similar formula is available for cos, a formula for 1 minus cos x is available. There is no formula for 1 minus sin x, but we have a formula for 1 minus cos x. 1 minus cos 2 theta is 2 sin square theta. We have two very useful formulae. One is 1 minus cos of 2 theta is 2 sin square theta, and second is 1 plus cos 2 theta, and this is equal to 2 cos square theta. So we do not have a formula for 1 minus sin x, but we have a formula for 1 minus cos x. So what we do is, we write this as 1 minus cos of pi by 2 minus x. Cos of pi by 2 minus x is sine of x. Cos of pi by 2 minus x lies in first quadrant, and this is odd multiple of pi by 2. So t ratio will change. We will add or delete co. So we can write this as sine of x. In this quadrant, cos is positive and this is odd multiple of pi by 2. So we will have, instead of cos, we will have sin x. We will have to change cos x into sin x. So we will have 1 minus sin x. This is equal to sin x. Whole divided by, I can write this as sine of pi by 2 minus sine of pi by 2 minus x, which can be written as tan inverse. Now 1 minus cos theta. 1 minus cos 2 theta is 2 sin square theta. So this will be 2 sin square 1 by 2 of pi by 2 minus x. We must have half of this. Whole divided by, now this must also be changed to the same angle, that is half of this. So we can use this formula. Sine of 2 theta is 2 sin theta cos theta. So we can write this as 2 sin 1 by 2 pi by 2 minus x into cos of 1 by 2 into pi by 2, and we can write this as minus x. Pi by 2 minus x. 1 by 2 pi by 2 minus x. Now 2 cancels with 2 and this cancels with this, and we are left with, this is equal to tan inverse of sine. This has cancelled. We are left with sine 1 by 2 into pi by 2 minus x whole divided by cos of 1 by 2 into pi by 2 minus x, and this is equal to tan inverse tangent of 1 by 2 into pi by 2 minus x. This is this. So we can write this as 1 by 2 pi by 2 minus x. Therefore, dy by dx is equal to, now this is d by dx of, this is pi by 4 minus x by 2. This is equal to, this is 0 and this is minus So minus half is the answer. And this question you can try yourself. Here again we have 1 plus sin x. There is no formula available for 1 plus sin x, so we will change it into 1 plus cos. So we can write this as 1 plus cos pi by 2 minus x. And this can be written as sine of pi by 2 minus x, as we did in this question. We will have 1 plus cos pi by 2 minus x, and we can use this formula and write this as 2 cos square 1 by 2 pi by 2 minus x, and this can be written as sine pi by 2 minus x, and you can use this formula and simplify this on similar lines. You can try this yourself. Now I am taking the second part. You can try the first part yourself. Y is equal to tan inverse under the root 1 plus sine x whole divided by 1 minus sine x. Now there is no formula for 1 plus sine x or 1 minus sine x, but we have 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. So we will change these two signs into cos. So we will write tan inverse, and as we have done earlier, we will write this as 1 plus cos pi by 2 minus x whole divided by 1 minus cos pi by 2 minus x, because we know cos pi by 2 minus x is sin x. And now we can apply these two formulae and write this as tan inverse under the root 1 plus cos. 1 plus cos is 2 cos square theta. So this will be 2 cos square half of pi by 2 minus x whole divided by, this will be 2 sine square theta. So this will be 2 sine square 1 by 2 into pi by 2 minus x. We can cancel this 2 and we get cot square 1 by 2 of pi by 2 minus x. Then write this as tan inverse under the root cot square 1 by 2 into pi by 2 minus x, and this is equal to tan inverse cotangent of pi by 4, this is pi by 4 minus x by 2, and we can write this as tan inverse. Now we know cotangent of theta is equal to tangent of pi by 2 minus theta, pi by 2 minus theta. Cotangent of theta is tangent of pi by 2 minus theta, because pi by 2 minus theta lies in first quadrant, therefore tangent is positive. And we have odd multiple of pi by 2 into 1, so we will attach or delete co. Cotangent will become tangent, tangent will become cotangent. Secant will become cosecant, cosecant will become secant. I have told this rule earlier. This can be written as tangent of pi by 2 minus pi by 4 minus x by 2. And this is equal to tan inverse of tangent of Now pi by 2 minus pi by 4. Pi by 2 minus pi by 4 is pi by 4. Minus minus plus x by 2. So this can be written as pi by 4 plus x by 2. And therefore dy by dx is equal to, this is differential of this is 0 and differential of this will be 1 by 2. And this question you can try yourself on similar lines. Now we are given y is equal to tan inverse of this, and we have to differentiate this function. But before differentiating it, we will simplify this question. Now in this question, because there is no formula available for 1 plus sin x and 1 minus sin x, we will change this into cos. We will write this as cos of pi by 2 minus x, this as minus cos pi by 2 minus x, this as this as this, and then proceed with the question. So this is equal to tan inverse of, now 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2. 1 plus cos 2 theta is 2 cos square theta. So 1 plus cos theta will be 2 cos square theta by 2. So this will be under the root 2 cos square 1 by 2 into pi by 2 minus x plus under the root, and 1 minus cos 2 theta is 2 sin square theta. We have used this formula earlier. This is 2 sin square 1 by 2 into pi by 2 minus x whole divided by under the root. This will be 2 cos square, again the same formula, 2 cos square 1 by 2 pi by 2 minus x minus under the root. Now this and this are same, we can write this as 2 sine square 1 by 2 into pi by 2 minus x, and this can be written as tan inverse into, now root 2 is common throughout and cancels, and we are left with under root of cos square will be cos. This will be cos of pi by 4 minus x by 2, and this will be sine of pi by 4 minus x by 2 whole divided by, this is cos of pi by 4 minus x by 2, and this square and under root cancels, we get minus sine of pi by 4 minus x by 2, and we can write this as tan inverse. Now if we divide numerator and denominator by cos of this angle, what we get is, we will get 1 plus tangent theta over 1 minus tangent theta, and we know 1 plus tangent theta over 1 minus tangent theta is equal to tangent of pi by 4 plus theta. Tangent of 45 plus theta is 1 plus tangent theta over 1 minus tangent theta. Tangent of a plus b is tangent a plus tangent b over 1 minus tangent a tangent b. But tangent of a is tangent of pi by 4, and tangent of pi by 4 is 1. So we will have 1 instead of tangent a. Tangent a 1 plus tangent b over 1 minus tangent a. Tangent a is 1 into tangent b. So formula for tangent pi by 4 plus theta is 1 plus tangent theta over 1 minus tangent theta. So we will arrive at this formula. So what we do is we divide numerator and denominator by cos of this angle. So what we get is tan inverse of 1 plus tangent pi by 4 minus x by 2 whole divided by 1 minus tangent of pi by 4 minus x by 2. And using this formula, we will get tan inverse of tangent pi by 4 plus theta. And theta is pi by 4 minus x by 2. Theta here is this much. Tan inverse and tan is identity function. Therefore, we will get tan inverse of tan x is x. So, we will get pi by 4 plus pi by 4 is pi by 2. Pi by 2 minus x by 2. And therefore, dy by dx is equal to, now this is 0 and differential of this is minus half. Differential of this is 0 and differential of this is minus 1 by 2. And this question you can try yourself on similar line. Change this into cos. 1 by cos, this will be sine over cos. So what we will get after taking the LCM? 1 plus sine x over cos x. And 1 plus sine x can be changed into this form and you can solve the question. Now next question is y is given to be this. And we have to find its differentiation. Now this can be written as cos inverse of 2x square minus 1. Cos inverse of 2x square minus 1. Because we know secant inverse of x is equal to cos inverse 1 by x. Tangent inverse x is cotangent inverse 1 by x. Reciprocal of tangent is cotangent. And similarly, we have cosecant inverse x is sine inverse 1 by x. So we can write secant inverse 1 by x as cos inverse of its reciprocal. Secant inverse x is cos inverse of its reciprocal. Tan inverse x is cot inverse reciprocal of this. Cosecant inverse x is sine inverse reciprocal of this. So we now have to differentiate this. One is I can directly differentiate it using the formula, or you can also put x equal to cos of theta, because this will then reduce into 2 cos square theta minus 1, and we know 2 cos square theta minus 1 is cos of 2 theta. So cos inverse and cos will cancel and we will get the result. So this can be written as this, and cos inverse 2 cos square theta minus 1. This formula must be in your mind when you are substituting x equal to this. All the formulae in trigonometry must be kept in mind. And for this you must search a formula for cos which is similar to this in pattern. Whose pattern is like this: 2 cos square x minus. Then substitute x equal to cos theta. So this will be cos inverse cos of 2 theta. And this is equal to 2 theta. And this is equal to 2, and theta will be equal to cos inverse x. X is cos theta, then theta will be cos inverse x. So this will be cos inverse x. And this can now be differentiated. dy by dx is equal to 2d by dx of cos inverse x, and this is equal to 2 into d by dx of cos inverse x is minus 1 upon under the root 1 minus x square. This is equal to minus 2 over under the root 1 minus x square. And in this question, what we will do is, we will search in the formulae for sine a formula having this pattern. 3 sine theta minus 4 sine cube theta is sine 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. So in order to solve this question, I will put x equal to sine theta. And in this we have a formula for tangent with this pattern. We know 3 tangent theta minus tangent cube theta over 1 minus 3 tangent square theta is tangent 3 theta. So we will put x equal to a tangent theta. So a cube will cancel out. Here we will have a square tangent square theta. So this a will cancel, and we will get 3 tangent theta minus tangent cube theta over, because a cube has cancelled, we will have 1 minus 3 tangent square theta, and this is equal to tangent of 3 theta. So you must search a formula in trigonometry with this pattern. This will be very helpful. To make the idea more clear, I am showing you a table. For example, we have cos 2a is equal to 2 cos square a minus 1. If in any question we have an expression of the type cos inverse 2x square minus 1, then the pattern of this question will match 2x square minus 1 is 2 cos square a minus 1. So if I substitute x equal to cos a, it will become 2 cos square a minus 1, which is cos of 2a. So cos inverse cos 2a will be equal to 2a. So there will be a simplification. In this, the pattern matches with 1 minus 2x square. 1 minus 2x square. So if we have cos inverse 1 minus 2x square, we will put x equal to sine a. The pattern here matches 1 minus x square over 1 plus x square. 1 minus x square over 1 plus x square. So put x equal to tangent of a. In this, pattern is 4x cube minus 3x. 4x cube minus 3x. Put x equal to cos of a. So this will become 4 cos cube a minus 3 cos a, which is cos of 3a. So cos inverse cos 3a will be 3a, and there will be a simplification. We can differentiate that. Here we have sine of 2a is 2 sine a cos a. Now cos a can be written as under root 1 minus sine square a. So pattern of this matches with 2x under root 1 minus x square. 2x under root 1 minus x square. And similarly, if I keep cos here and change sine into 1 minus cos square a, again the pattern is same. So both substitutions can be made. Put x equal to sine a or put x equal to cos a. In this, the pattern matches with 2x over 1 plus x square. So put x equal to tangent a. Here it matches with x equal to sine a. Here it is tangent a plus tangent b over 1 minus tangent a tangent b. Tangent a plus tangent b over 1 minus tangent a tangent. Let alpha be equal to tangent of a and x be equal to tangent of b. Then this will be tangent a plus tangent b over 1 minus tangent a tangent b. And this will become tangent of a plus b. So tan inverse and tan will give a plus b. Similarly, the pattern here matches with this. You can see this table. If pattern is like this, we will put x equal to tangent A and it will change into tangent of 2A. Tangent of 2A. And you can see in these two, it is 2x over 1 plus x square. Here it is 2x over 1 minus x square. Here it will change into sine of 2A. And here it will change into tangent of 2A. In both we substitute x equal to tangent of A. Here we have tangent 3A is this one. So 3x minus x cube, 3x minus x cube, 1 minus 3x square, 1 minus 3x square. So substitute x equal to tangent A. So these substitutions will strike you. If you remember this formulae and observe the pattern, then the substitution will come to your mind. The substitution will strike you. Here put x equal to cos of 2A, because we have 1 minus cos 2A, 1 plus cos 2A. And also if we have 1 minus x and 1 plus x both are involved, substitution should be x equal to cos of 2A, because for both we have a formula. 1 minus cos 2A is 2 sin square A and 1 plus cos 2A is 2 cos square A. So for both plus and minus we have a formula. So it also indicates that we must substitute x equal to cos 2A. But here a direct formula is available. If that formula is not available and in any question you have both 1 minus x and 1 plus x, then substitution will be x equal to cos of 2. Here it is sin A plus minus B is sin A cos B plus minus cos A sin B. So if we have a question like sin inverse A cos B minus B sin B, then we will put A equal to R sin alpha, B equal to R cos alpha. So we will have R sin alpha cos B plus R cos alpha sin B. So we will have sin alpha cos B plus cos alpha sin B. So we will have the formula for sin A plus B. Similarly, you can see the other trigonometrical formulae. So this idea is now clear. Observe the pattern in the formula and make the corresponding substitution. Now I come to the main question. So now we see that we have sine inverse 3x minus 4x cube. So the formula corresponding to this pattern is 3 sine A minus 4 sine cube A, which is sine of 3A. So substitution should be x equal to sine A. You can try this yourself. I am taking this question. Y is equal to tan inverse 3a square x minus x cube whole divided by a cube minus 3ax square. Put x equal to a tangent theta. Put x equal to a tangent theta, because we have a formula of whose pattern is similar to this. 3 tangent theta minus tangent cube theta is 1 minus 3 tangent square theta. You can see the side sheet. So what we get is y is equal to tan inverse 3a square into a tangent theta minus a cube tangent cube theta whole divided by a cube minus 3a into a square tan square theta. Now a cube is common. A square into a is a cube, a cube, a cube. So we cancel a cube throughout. And we are left with tan inverse 3 tangent theta minus tangent cube theta over 1 minus 3 tangent square theta. Therefore, what we get is y is tan inverse a cube cancels and we get 3 tangent theta minus tan cube theta whole divided by 1 minus 3 tan square theta. This is equal to tan inverse tangent of 3 theta, and this is equal to 3 theta. We substituted x equal to a tangent theta, and this implies tangent of theta is equal to x by a, and this implies theta is equal to tan inverse x by a. Theta is equal to tan inverse x by a. So this is equal to 3 tan inverse x by a. Now we differentiate both sides. What we get is dy by dx is equal to 3 into d by dx of tan inverse x by a. Tan inverse x by a. This is equal to 3 into 1 upon differential of tan inverse x is 1 over 1 plus x square. 1 plus x square, x by a whole square into. Now independent variable is x, but we are having the inner function as x by a. So we must take differentiation of this function. D by dx of inner function. Inner function is x by a instead of x. So what we get is 3 into. Now 1 upon a square is the LCM, and we get to a square plus x square into d by dx of this will be 1 by a. So what we get is 3a square whole divided by a square plus x square into 1 by a, and this is equal to a cancels with a, and we get 3a divided by a square plus x square. This a cancel, 3a over a square plus x square, and this is the answer. And similarly, you can try this. Put x equal to sine theta and you will get the answer. We are given y is equal to tan inverse a cos x minus b sin x over b cos x plus a sin x. If I put a is equal to r sin lambda and b equal to r cos lambda, what we will get, r will be common and we will have sin lambda cos x minus cos lambda sin x. Sin a cos b minus cos a sin b, which will be sin of a minus b. And similarly, here we will get r cos lambda cos x plus r sin lambda sin x. R will be common, we will have cos lambda cos x plus sin lambda sin x. And this will give cos of a minus b. So this question will be simplified. So we make these two substitutions. Now substituting in one, we get y is equal to tan inverse a is r sin lambda cos x, r sin lambda cos x, minus b is r cos lambda sin x. We have r sin lambda is r sin lambda cos x minus r cos lambda sin x whole divided by b is r cos lambda. R cos lambda into cos x plus a is r sin lambda into sin x. This is equal to tan inverse Now r is common. R is common and we are left with sine A cos B minus cos A sine B, which is sine of A minus B. That is sine of lambda minus x. And in the denominator we have r cos A cos B plus sine A sine B. This is cos of A minus B. So we have cos of lambda minus x. Now this r cancels with this. And we have tan inverse tangent of lambda minus x, which is equal to lambda minus x. Therefore, dy by dx is equal to, now lambda is constant, a and b are constants, so lambda and r are both constants. So differential of constant is 0 and we have minus 1 as the answer. Now in this question what we do is, second part I will not complete it, I will give you only a hint. Y is equal to tan inverse A plus B tangent x whole divided by B minus A tangent x. Now what I do is I divide both numerator and denominator by B. What we get is tan inverse A by B plus tan x whole divided by 1 minus A by B tangent x. Put A by B equal to tangent of lambda. Lambda is a constant. So what we get is y is equal to tan inverse tangent lambda plus tangent x whole divided by 1 minus tangent lambda tangent x. And this is tangent of A plus B. That is tangent of lambda plus x. Tan inverse and tan of lambda plus x will give lambda plus x, and you can differentiate it and get the result. This you can try yourself. Now in the previous questions what we observed is, if the pattern of the expression involved in the question matches with the pattern of some trigonometrical formula, then make the substitution accordingly. But there are 2-3 more ideas. These are only ideas. These are not rules. You can try them. They may be successful or not. These are only ideas. If algebraic expression involved in a question is a square minus x square, we try x equal to a sine theta or a cos theta. If expression is a square plus x square, we try x equal to a tangent theta or a cotangent theta. If expression is x square minus a square, we try x equal to a secant theta or x equal to a cosecant theta. If both under root a square plus x and under root a minus x are involved, we substitute x equal to a cos 2 theta. Because for both 1 plus cos 2 theta and 1 minus cos 2 theta, we have a formula. This is 2 cos square theta and this will be 2 sin square theta. If we have a plus minus x, both are involved, these formulae will help. So we try x equal to a cos 2 theta. If instead of a plus x we have a square plus x square, then we substitute x square equal to a square cos theta. X square equal to a square cos 2 theta. If both these are involved, we try this. These are not rules, but these are only ideas. You can try them. You have to try them and see whether the question is solved or not. With practice, you will start having an idea whether this substitution will work or not. One or two steps you have to calculate orally. Now in this question, we are given y equal to tan inverse under root 1 plus x square plus x. Now under root 1 plus x square is involved. So we can try the substitution x equal to tangent of theta. A is 1. We can try x equal to tangent theta. What we get is y is equal to tan inverse under root 1 plus tan square theta plus tangent theta. And this is equal to tan inverse under root 1 plus tan square. 1 plus tan square is secant square theta. Secant square theta plus tangent theta. That is tan inverse secant theta plus tangent theta. Now we simplify this. So what we get is tan inverse 1 upon cos theta plus sin theta over cos theta. And this is equal to tan inverse 1 plus sin theta over cos theta. Now no formula for 1 plus sin theta is available, but we have a formula for 1 plus cos theta. So what we do is we write this as 1 plus cos pi by 2 minus theta over, and this can also be written as sine of pi by 2 minus theta. Both these angles should be kept same. 1 plus cos 2 theta is 2 cos square theta. Therefore, tan inverse of 1 plus cos pi by 2 minus theta can be written as 2 cos square half of pi by 2 minus theta using this formula, whole divided by 2 sine half of pi by 2 minus theta, half pi by 2 minus theta into cos of half pi by 2 minus theta. Now this 2 cancels with this, and cos this cancels with this, and we are left with cos half pi by 2 minus theta over sine half pi by 2 minus theta, which is cotangent of half pi by 2 minus theta. So we can write this as tan inverse of cotangent half pi by 2 minus theta. Now cotangent half pi by 2 minus theta can be written as tangent inverse of tangent pi by 2 minus half of pi by 2 minus theta, because we know tangent of pi by 2 minus theta is equal to cotangent of theta. So we can write this cotangent theta as tangent of pi by 2 minus this angle. So this is equal to, now tan inverse and tan become identity function. So therefore this will be equal to pi by 2 minus this. So this can be written as pi by 2 minus. Now open this bracket, we have pi by 4 minus plus theta by 2. Pi by 2 minus pi by 4 plus theta by 2. So this is equal to pi by 2 minus pi by 4 is pi by 4. So pi by 4 plus theta by 2. Pi by 4 plus theta by 2. Now theta is tan inverse x. So we can write this as pi by 4 plus half of tan inverse x. Half of tan inverse x. And therefore dy by dx is equal to, now differentiation of this is 0, this being a constant, plus half into d by dx of tan inverse x. Differentiation of tan inverse x is 1 upon 1 plus x square. So this is equal to 1 by 2 into 1 plus x square. Answer. So here we get a cotangent of this, but this cotangent can be changed into tangent, and we get this angle. Now next question is, we are given y equal to tan inverse of this. Now what we note here is, we have both 1 plus x square and 1 minus x square in this question. And corresponding to this, we have a formula for both plus minus in cos. We have 1 plus cos 2 theta and 1 minus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. So we substitute x square equal to cos 2 theta. So 2 theta must be cos inverse x square, and theta therefore must be 1 by 2 cos inverse x square. Now we substitute this in this equation. Y is equal to tan inverse under root 1 plus x square is cos 2 theta. Cos 2 theta plus under root 1 minus x square, that is 1 minus cos of 2 theta, whole divided by under root 1 plus cos 2 theta. 1 plus cos 2 theta minus under the root 1 minus cos 2 theta. Now we know 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. So we write tan inverse of under the root 2 cos square theta plus under the root 2 sin square theta, whole divided by 1 plus cos 2 theta is under root 2 cos square theta minus under root 1 minus cos 2 theta is 2 sin square theta, and this is equal to tan inverse, root 2 is common in the numerator and denominator and cancels, and we are left with under root of cos square theta, that is cos theta plus sin theta whole divided by cos theta minus sin theta. Now what we do is, we divide the numerator and denominator by cos of theta. So what we will get is 1 plus sin theta over cos theta, that is tangent theta. 1 plus tangent theta over 1 minus tangent theta. 1 plus tangent theta over 1 minus tangent theta, and 1 plus tangent theta over 1 minus tangent theta is tangent of 45 plus theta, tangent of pi by 4 plus theta. So this tan inverse and tan will go, and we will get pi by 4 plus theta. So what we do is, we divide the numerator and denominator by cos theta. So what we get is 1 plus sin theta over cos theta is tangent theta, whole divided by, now divide by cos theta, 1 minus sin theta over cos theta is tangent of theta. Divide numerator and denominator by cos theta, we will get 1 plus tangent theta over 1 minus tangent theta, and this is equal to tan inverse tan of pi by 4 plus theta. and this is equal to pi by 4 plus theta. This is equal to pi by 4 plus, from 2 theta is 1 by 2 cos inverse x square, 1 by 2 cos inverse x square, and therefore dy by dx is equal to, now differential of constant is 0 plus 1 by 2 into dy by dx of cos inverse x square. This will be minus 1 upon under the root 1 minus x square. Differential of cos inverse x is minus 1 over under root 1 minus x square. But instead of x we have x square. So it will be minus 1 over under root 1 minus x square, square is x4 into d by dx of inner function. Inner function is x square. And this is equal to 0 minus 1 by 2 under the root 1 minus x4 into 2x. Differential of x square is 2x. So this 2 cancels with this and we get minus x over under the root 1 minus x4. So this is the answer. And similarly, on similar lines, you can try this question. Put x equal to a cos 2 theta. What we will get is, because we are having both a minus x and a plus x, we will get 1 minus cos 2 theta or 1 plus cos 2 theta. And formula for 1 minus cos 2 theta and 1 plus cos 2 theta both is available. So this question will be solved. What we do is we put x equal to a cos 2 theta.